Welcome to another lecture from my Advanced Data Modeling class at the University of Minnesota, Carlson School of Management. Part 1 of this lecture in Subtypes Supertypes puts that in the broader context of generalization. In my view, generalization is a type of abstraction. We can generalize attributes, we can generalize relationships, but most importantly, we can generalize entities, and it is the constructs of subtypes and supertypes that are used there. I call subtypes and supertypes the most valuable construct for data modeling. Why is that? Well, number one, it allows us to handle the case of overlapping entity type populations. In contrast to the assumption made in relational DBMSs, that all entity type populations are mutually exclusive. And when they're not, what do we do about that? Number two, it enables the formal representation of generalization, specialization of entity types. Number three, it allows the data modeler to defer where to build the tables, at what level in the subtype supertype hierarchy. Now, in viewing this presentation, you may not see me, and that's probably a good thing. Rather, you'll see the slides given in a live lecture and will hear questions being asked by the students. It's helpful, though not necessary, to have a copy of the slides. You may go to my website, geverest.umn.edu, how to obtain a copy of the slides.
Okay, the subject of subtypes and supertypes. In the industry, my judgment is that some data modelers haven't even heard of subtypes and supertypes. And for the vast majority of those that have, they don't really understand it. This happens to be probably the most popular talk that I'm asked to go to other DEMA chapters and give, is on subtypes and supertypes. I guess they figure out I know what I'm talking about. And I guess I have to confess that I think I do. Part of the reason why it's so relevant is because it applies not only to object role modeling, but it applies equally well to relational modeling or ER modeling or UML or object modeling, whatever it happens to be. We'll talk first about the notion of abstractions, collections, and generalization. We'll talk about three different kinds of generalization, and then entity generalization is called subtype supertypes. And we'll talk about the assumptions and diagramming methods and so on. Then constraints on a subtype supertype relationship, the definition of the subtype, which defines what is allowed to appear in a subtype population. Talk about the notion of the hierarchy, inheritance questions, and when I get into there, I'm going to talk about the contrast between subtypes and supertypes in the context of data modeling vis-a-vis in the context of object-oriented programming, design, whatever. Or some people just refer to it as object modeling, but object modeling has nothing to do with object role modeling. It's object-oriented modeling. And then finally, how you map to tables. And that's what the designer has to do if they don't know about subtypes and supertypes, but those notions, or let's say the things that cause them to be included, they have to compensate and decide through that. They have to actually pick the tables up front. When you have the ability to define subtypes and supertypes, then you can defer the question of where do I build my tables. And that's really a good thing. All right, I call it the data modeler's most valuable construct. So what are the constructs that we so far have used in data modeling? We've talked about entities. We've talked about attributes, right? We've talked about identifiers. We've talked about relationships. Okay? All of these things. In fact, the difference in what emphasis we put is what distinguishes some of these modeling schemes. Relational kind of suppresses the notion of an attribute and it has to be embodied in the notion of a foreign key, which is an attribute. And ER modeling, if we say we're just going to draw boxes for the entities, we're kind of suppressing the display of the attributes, but they are nonetheless there. Well, we're introducing another type of construct when we talk about subtypes and supertypes. Let's motivate this. If I just showed you a customer object type and an employee object type, what does that mean? What does that communicate to you? Or what can you tell me that this tells you? I'm looking for some really obvious things. And when I draw a box and put a name on it, there's a population of things of those things. So I say there's a population of customers. What else? There's a type that I've given it, and also that there is an underlying population. Are these populations disjoint? So now I'm hearing no. Now you're drawing upon in what you understand is meant by customer and employee. And that's probably valid. An employee could be a customer. But what is the system assuming? Remember we said a basic principle relating to object types or entity types in an ER model is that there is never any overlap. Okay? All object populations are mutually exclusive. That's the assumption made by the system. And if you know that not to be true, as in this case, what are you going to do about it? Well, the answer is you're going to model using subtypes and supertypes, because that's what it allows you to do. At the very base, subtypes and supertypes allows you to model overlapping populations. Okay? And so it overcomes that assumption. Would there be some things in common across customer and employee? Name? Birth date? Could a customer be an organization? Depends how you want to define it. Probably an employee couldn't be, right? And then we need to understand the population. Like an employee, could that be applicants, retirees, people furloughed? When I talk about customer, what about somebody who's never ordered a product? Are there preferred customers? Okay? It's important that we clearly define what the population is that we're talking about. So, just some definitions here, and this is important because there's a fair bit of disagreement as to what some of these terms mean in the field. I've got some of the key references up there of people who have talked about the notion of abstractions and subtypes and supertypes. The first one, Smith and Smith, was probably the first one that tried to put together a sort of a taxonomy of these things. And they talked about classification, aggregation, and generalization. John Smith and I were roommates when we were at the University of Pennsylvania. I had an opportunity to review his first paper that he was publishing on this. So there was kind of a connection there. Anyway. So abstractions, and this is used in a different sense. He used it in a different sense. It's sort of like the umbrella. Classification simply means you're a member of. And that's what we do when we draw a box and call an employee. We are classifying out of all of the things in the world, we're saying the members of this population are classified as employees. So classification is the thing that we do when we form types. Aggregation is things that we do when we cluster attributes together as descriptions of objects. So you could think of that as part of. The first one would be like member of a population, part of the description of a population. Composition would be a stronger part of, where there can be no separate independent existence. And I'm not going to go into any of these in any more detail than what's here. The third one would be generalization, the opposite being specialization, and some people refer to that as the is-a relationship. Because we say a cow is an animal. Okay? And that's the generalization. Horses are also animals, and rabbits are also animals. So the notion of animal is a more general notion than cows and horses and so on. And that's what leads us to talk about subtypes and supertypes. Now, when we talk about a homogeneous population, anything when we throw them into a population, we're saying all those members are homogeneous, at least from some perspective. Now, when we throw them in, we can be talking about set collections. And in a set collection, there can be no duplicates and there's no order. Ordering doesn't matter. But in the OO world and a lot of other disciplines in the world, we have to distinguish. In the relational model, we can only talk about sets. But in the OO world, they found it's meaningful to talk about other kinds of collections. And I mentioned two of them here. A bag is used if we count duplicates. That's a different kind of a collection than a set. And a sequence where order matters. Let me focus in on generalization now. Let me just say that some people refer to generalization as abstraction. And I find that's difficult. I don't use the term abstraction in the more general sense, covering all of those things that we saw before. I use abstraction as a scheme for hiding detail. Okay? And that's what the term abstract actually means. It means leaving something out. But we'll come back to that when we talk about presentation. So generalization fundamentally is recognizing commonalities. Where is there commonality across members of a population? And then you want to ask the user, do you care? Is it useful to distinguish those? And if I do, what's the cost? Generalization is moving up to a higher, more inclusive, more generic, more abstract view. And I put abstract in quotes because that's not the way I want to use that term. Along with that, there's classification and aggregation, and then generalization, and within generalization, there's three kinds: attribute, entity, and relationship generalization. So there's attribute generalization, and we'll go through and describe each one of those, but we're going to focus mostly on entity generalization. Okay, let's suppose that I'm building a database for a tuxedo rental shop. And one of the things they want to store about their customers are their waist size, their leg length, and so on, so that they can properly fit their customer. Okay, so far so good. Let's suppose that I design a database and I got those 5 columns, and later I want to add shoe size. What does that do to the schema for the database that I've defined? What do I have to do to incorporate shoe size?
Define populations?
Oh, I'll certainly do that. I'll define a population, but I'm telling you that there's a relationship now between customer and shoe size. What am I going to do? I'm just going to add another column to the table, right? And then what do you suppose is going to come next? We got neck size, shoe size, arm length, shoulder length. But you'll get another size of something. Maybe hat size. I don't have that yet. You got hat size. And then there's another one, and then there's another one. Do you see what's happening here? These are all sort of the same kind of thing. And if I generalize, it might make it easier. Okay, what does it do to the schema? It means we have to change it. How might we solve the problem? How we might solve the problem would be to define a pair to say measurement type and measure. And now it's going to be a repeating group, isn't it, within the customer table. Of course, the relational model doesn't like that because it's a whole other file. How does referential integrity become important here? Remember what referential integrity is? It says that the value in this field has to exist somewhere over in that other table. So, would I need referential integrity on the field that's called measurement type? I probably would, right? Here are the different kinds of measurements that we can be recording. And then, if anybody wants to add another measure, like ring size maybe, they just add another row to that table. Okay? Now, what's the downside of this? I can no longer talk about waist size or leg length or whatever. When I address querying, for example, when I query this table, I have to be talking about measurement type. Okay? Now, what does it also do to the integrity constraint that says this is the range of numbers that makes sense? So what might be the range on shoe size? Well, it might be, I don't know, 4 to 14. Would that be relevant for waist size? No. So, but I've got one column of numbers. The dumbest thing in current DBMSs is that you can't declare conditional constraints. In other words, say, if the field over here is waist size, then the values that are going to be here are in this range. So how do we handle it in most DBMSs? You write a special piece of code, a stored procedure.
So I know that in SQL you can make a settings for the attribute in an entity. So is that a solution?
Explain settings for an attribute.
Because like when I took 3103, we did some SQL on Toad, and for the attribute in an entity, we can actually set up the unit
Yes.
of that attribute. So is that going to be?
No, it doesn't solve your problem. That declaration will apply to all values that appear in the whole column. When I'm talking about conditional, it has to be only on some of them based upon the value in something else. So there's some commonality here that makes sense for generalization. Consider phone numbers. We might set up phone numbers, and then I'll tell you, let's say we want to store international phone numbers. Do international phone numbers look like US phone numbers? Some of them do, but a lot of them don't. Notwithstanding that the ITU is trying very hard to get the whole world move to 3, 3, and 4. Okay? But it's not required yet. Handling contact information. Phone numbers are contact information, but is a pager number? Well, that looks like the same. Is an email address. Is an email address contact information? Yeah, but it has a different format. I can declare, since all the figures in the entire column of waist size are going to be in certain range, I can declare an integrity constraint on that. But if I generalize, I no longer can. That's my point. It's not usually the users that want to generalize attributes. It's usually the systems developers, the systems designers, because for them, it's a lot easier if you don't have to go back and change the schema. That's major surgery in any database environment. Okay? Generalization avoids that. So, what do you observe here? Across customer, supplier, and associate. Does it look like there's some commonality? I think you'd find there is, in names, in addresses, in phone numbers. Okay? A little bit different from one to the other. Well, that suggests perhaps generalizing. Give me another example of attribute generalization. If I had a table that was defined like this, okay, so I've got the year and the department, and then I have a field specifically defined for each of the 4 quarters and the budget and the labor or material costs, whether it's budget or actual during that period. Okay? How many rows would you have? Well, you can figure that out. I got 4 quarters, I got budget versus actual, and then I've got material and labor and capital. What would you want to do? We just generalized before in that previous example. Would it not make sense to generalize here as well? Well, it would. Okay? So I'll put department, year, quarter, budget, actual, and category all in the same line. And notice I need all of those to uniquely identify the amount, the dollar figure. Now, for those of you who care, in the dimensional model or star schema, that is precisely the fact table. And it's got those 5 dimensions, every fact that's in the fact table. So, the extreme for attribute generalization, because you can keep going up and up and up in this generalization hierarchy. This is the definition of the database that we're storing. I could have a table of all the entities in my data model, an identifier and a name for each one of those, and then for each attribute I could have stored the name and the entity and a value. Would this be a meaningful way to store my data? Sure, it's logically equivalent, but I've lost a lot. How many rows would there be here in this attribute table? As many attributes as there are in my database, right? What's lost here? Where are the attribute names? They're buried in the data, aren't they? Because they're values in these tables. What is hard? Can you imagine yourself writing queries to get information out of this? You can do it, but it's going to be pretty convoluted. Users aren't going to like this. So querying would be difficult. Expressing, as we explained before, expressing constraints across these would be very difficult as well. But what's really easy? And it's the system developers and the designers that just love it. It's easy to add an attribute to a table. It's just another entry in the attribute table. What else might be of interest about an attribute besides the value and the name? Anything? Is that all we'd ever want to store? We usually have a lot more information about an attribute, don't we? I mean, very simply, we'd have things like data type. Okay? In fact, I could suggest all kinds of things besides the name and the value. The type, the size, the precision, the units of measurement, the date it was last updated, the source of it, etc., etc., etc. Okay? Do some tracking, etc. Okay? The level of confidence that we can have in it. This demonstrates the power of generalized thinking. But remember, there are downsides. Now, I've been to an all-day seminar of somebody who's talking about abstractions. He was really talking all about generalization and could say nothing but good. Never put forth the idea that there's a downside to this generalization. If you find yourself mixing value domains, then you may be generalizing too much. Okay? There may be an upside, but there's a downside, and you need to balance those as you think about the design process. All right, just one slide on relationship generalization. I could have owner, beneficiary, and insured in the relationships between person and an insurance policy, for example. Or I could generalize that and just have one relationship depicted between the two of them. Now, of course, there is a role, right? Because those aren't all the same kind of relationship. At one level, they are, but if I want to distinguish them by owner, beneficiary, and insured, I would have to add some information here, okay? Like the role. Now, the role is a characteristic of what? Not the person, nor the policy. It's basically an attribute of the relationship, and people refer to that sometimes as an attributed relationship. I don't find that particularly helpful. We could add to this person involved in accident with the car that was insured under the policy. Lots of other things can stem from this. Okay? How many foreign key? Oh, where would you store the role attribute? If it's a many-to-many relationship, you can't store it in either side. Okay? Now the way we showed it up above, it was each one of those was a one-to-many relationship. So where, if that were the case, there could only be one owner, one beneficiary, and one insured under an insurance policy. Where am I going to store the foreign key? I would store it with the insurance policy, right? How many foreign keys will I have? Can I have one? I'd have to have 3 of them, wouldn't I? Just a summary before we jump into subtype supertypes. Generalization, pros and cons. The pluses are the pros and the minuses are the cons. It results in fewer entities and fewer relationships. Now that's a plus, but you have to ask yourself, does that really make it simpler? Greater flexibility to incorporate extensions, and that's why the systems people like it so much. Greater long-term stability of the model. Again, for the same reason, because the schema doesn't have to change. You just add some more data to it. We are looking for commonalities, and that itself can lead to greater understanding. We can have special treatment of subsets. Downsides, it hides business vocabulary. You can no longer talk about waist size. Okay, you can't say, give me all of those people who have a waist size equal to something, because the system doesn't understand waist size as a column heading. You have to say where measurement type equals waist size. It's harder to express and enforce the business rules. We talked about that. We need to have conditional rules. But I don't know of any DBMSs today. I do know of one that existed in the past that allow you to declare conditional constraints. And it would be so easy and simple to do that. You have a problem defining identifiers, reference modes. Queries are more difficult. And I'm showing you an example there. Find customers where waist size equals 42 no longer work.